In this video, I'm going to be explaining the relationship between angle measurements and their opposite side lengths, as well as the triangle inequality theorem and what three side lengths actually form a triangle. So there are special relationships between a side length and the angle opposite from it or across from it. If we use this example, we can measure the angles and we can measure the side lengths, and then we can order them, which one's bigger, which one's smaller. So by doing so, we find that the shortest side length is going to be side AC or side B, segment AC or side B. The longest side is going to be segment AB or side C, and the one in the middle is going to be side A or segment BC. The smallest angle we're going to discover is angle B, and the smallest, or the biggest angle, is angle C, and so angle A is going to be in between them. So what can we discover by looking at these measurements and side lengths? Well, hopefully you can see that the shortest side, this side, is across from the smallest angle. And that the biggest side, side AB, is across from the biggest angle. And the reason why those side lengths relate to the angle measures is because these angles are actually creating this side length. So if I open up angle B, that opening is creating this measurement or this side length right here. So the bigger the opening, the longer this segment over here is going to be. Or the smaller this angle opening, the smaller that side length is going to be. So angle measures always relate to the side length directly across from them or opposite from them. And we can come up with this conclusion that the shortest side is always going to be across from the smallest angle, and the largest angle is always going to be across from the longest side. That's always true in a triangle. Those angles, those measurements are creating the side length across from them. So the bigger the angle, the longer the side. The smaller the angle, the smaller the side. So then we can start to order things from biggest to smallest or from smallest to biggest. So let's list the angles in this triangle from least to greatest. So from smallest to biggest. Angle B was the smallest, angle C was the biggest, and angle A was in the middle. We could order the sides. This time we're going to order them from biggest to smallest. So the biggest side was segment AB, the smallest side was segment AC, and segment BC was somewhere in the middle. So even though we don't know the exact measurements, we can still order things from biggest to smallest or smallest to biggest. So in this example, we know the angle measurements, and we want to determine which side is longer and which side is smaller. So based on the angle measurements, if I look for the smallest angle, I know that across from it or opposite from it is going to be the shortest side. So if I want to order from smallest to biggest, side or segment CA is going to be the smallest. And then we can just go up from there. So the next biggest angle is 60 degrees. So the middle segment or middle side is going to be segment BC or CB. And then the biggest angle is 70 degrees. So across from that, that side is going to be the longest side. So segment AB or BA is the longest side. We can go backwards. We could be given the side lengths and then have to order the angles. We don't know the measurements, but we know which one's bigger and which one's smaller. So this time we're asked to order from biggest to smallest or from greatest to least. So I'm looking for the biggest angle. Well, the biggest angle is going to be across from the biggest side. So angle A is the biggest. 6 inches comes next. So across from that is angle C, that would be in the middle. And then the smallest side length is 4.5 inches. So across from that is going to be the smallest angle. So angle B is our smallest angle. That leads us into the triangle inequality theorem. The triangle inequality theorem describes side lengths. So if I'm given 3 side lengths, can I determine whether or not they actually form a triangle or not? The triangle inequality theorem is sometimes described in a difficult way. Sometimes it's said that the sum of the measures of any 2 sides of a triangle must be greater than the measure of the third side. So by using that definition, you're going to have to do 3 comparisons. That's not quite necessary. Really, what we need to check is that the 2 shortest sides add up to be bigger than the third side. If we do that check, That's all we need. So really, in the parentheses is our shortcut. As long as we can add up or find the sum of the two shortest sides and check to make sure it's bigger than the longest side or the third side, then we know that we've created a triangle. Notice that it doesn't say they could be equal or less than. So the sum of the two shortest sides has to be bigger than, not equal, not less than. So given three possible measurements or side lengths of a triangle, do they form a triangle? So we're always going to ask ourselves this one question. Is the two smaller sides adding up to be bigger than that third side? So locate the two smaller values. In this case, we would have 6 and 5. Do they add up to be bigger than that third side? Well, is 5 plus 6 bigger than 12? The answer is no. So these lengths will not create a triangle. And the reason why is because these two smaller side lengths have to touch. And they're coming from this side length. So they're attached to this bigger side length, and then they're having to join up and become longer than that. And if they don't, then they don't touch and we don't form a triangle. So you can use 3 pieces of string or 3 pieces of paper to really visualize and check this theorem. Let's move on to another example. So we're just using different number types here. So in this case, do the two smaller side lengths or two smaller lengths add up to be bigger than that third one? So 5.2 and 4.8 are the two smaller ones. Do they add up to be bigger than 9.1? Well, yeah, 5.2 and 4.8 give us 10, which is bigger than 9.1, so that forms a triangle. So decimals and integers are easy enough, but what happens if we have fractional side lengths? Well, in order to compare fractions, we need common denominators. So if I change each of these to a common denominator, I would choose 12, and then I could compare them by using the common denominator. So 1/2 is the same as 6/12, 1/4 is the same as 3/12, and 1/3 is the same as 4/12. So the two smaller values here are 1/4 and 1/3, or 3/12 and 4/12. They combine to give me 7/12. And is 7/12 bigger than 1/2 or 6/12? Yes. So those actually form a triangle as well. So we got two sets that form a triangle, one that does not. And again, remember, if my two smaller side lengths add up to be equal to that third side, that is also not a triangle. So there it is, the triangle inequality theorem. Two shorter sides have to add up to be longer than the third side. And angle relationships compared to their sides. The smaller angle is always across from the smaller side. The bigger angle is always across from the bigger side.